Hello student, today we are going to discuss about chapter number 6, which is pure substance, elements and compound. Okay. Now, in this very particular chapter, we are going to learn about various type of things. Okay, and this type of things which we are going to learn now, it might not be very important for our class, but these very things are very important in the higher classes. Okay, because these are the basics here now. Now we are going to learn about pure substance, means we are going to know that the substances which are present around us are pure or not pure. Okay, or to whom we can say the pure substances. And then we are going to learn about elements and compounds. Okay, what are elements, what are compounds, how they are made, and what are the requirements for making them. Okay. Now, first of all, the topic is here, the element here. Now, if you read the definition here, what is written here? The element is a simple substance that cannot be broken down into more simpler substances. It means that element is a very simple substance which cannot be broken down into any other substance. Suppose like hydrogen. Hydrogen is itself an element, okay, and you cannot break the hydrogen into some other thing. Hydrogen will always remain the hydrogen here. So, an element is a simple substance that cannot be broken down into simpler substances. Like example, I have given a hydrogen, oxygen, iron, and there are many more. Okay, if you look in the book, you will be getting that total there are how many? 118 elements are there. We have discussed only few of them. Okay. Now, the next topic is your compound. Now, what is compound here? You can just see the definition where two or more elements. Okay, any two, because when you are saying two or more elements, does not mean that all the elements they can combine with each other. Okay, some of them they will combine with each other, some of them they might not combine with each other. Okay, but if two or more elements, if they chemically combine together, then they will give rise to the form of compound. Okay, now like I have given some example here like H2O, CO2, NaCl, MgOH2. This type of things might be very new for you, okay? But this is the formula for water. H2O is the formula for water. CO2 is the formula for carbon dioxide. NaCl is the formula for sodium chloride. Like in the home, we used to use salt for eating, isn't it? That salt formula is what? NaCl here, sodium chloride. Even similarly, we have magnesium hydroxide, and there are enormous compounds are there. Okay? Many millions are there here. So now here, what you can see here, you can see that for the formation of water, what did I require? I require hydrogen and oxygen. There are how many elements here? These two elements, they combine together and they form the water. Now here you can see CO2, means here carbon and oxygen. This carbon and oxygen they combine to form carbon dioxide. Okay. Now you might be thinking in your mind that why the formula for water is H2O and why the formula for carbon dioxide is CO2. Okay. Now for that type of concept, we will be going to the other part. Okay. Now as you can see here, this is NaCl, sodium chloride, MgOH2, this is magnesium hydroxide here. So this is element, this is compound. Elements are smallest substance, they cannot be broken down into any more simpler substances, like example hydrogen, oxygen, iron, etc. And compounds are those substances which are formed by the combining of two elements, or it can be more than two elements. Like if you take an example of here, this is magnesium hydroxide. You can see here magnesium hydroxide is formed by what? Mg is your magnesium, O is your oxygen, H is your hydrogen. Okay. Now here when I am talking about the formula for water as H2O, what does it mean? It means that we will be requiring two hydrogen atom, okay, and one oxygen atom. Means when two hydrogen atom and one oxygen atom will combine together, they will give rise to water. Similarly, if I go to carbon dioxide, we have your CnO. That means one carbon and how many oxygen here? Two oxygen. That means one carbon when it is combined with two oxygen, that will give rise to carbon dioxide. Similarly, it is here NaCl. It's made up of two elements. With the sodium and chlorine. Here it means that one sodium atom is going to combine with one chlorine atom to form sodium chloride here. Now next definition is your atoms here. Now you see this all the properties that I have written for the atom, they are not only the properties, they is the definition of the atoms here. Now first what they say here, the atom is the smallest part of an element. That means and it has all the properties of the element. That means that atom is the smallest indivisible particle. Indivisible means it cannot be broken down anymore further here. So atom is the smallest indivisible particle of an element which will contain all the properties of the element. Means whatever properties the element has, it is going to be with that particular atom. Suppose if I say gold, that means the gold atom, that means the gold atom is going to have all the properties of gold. If I say silver atom, that means the silver atom is going to have all the properties of silver here. Number two, what we have here? A pure element is made up of atoms of same kind. That means it's very simple to understand. Okay. Now, if I take milk, it's just an example. Okay. Now, if I take the milk and add water to it, okay, will you tell that this milk is a pure milk? we will not be saying because we have added some extra amount of water. But if I don't add water, then I can say that it is a pure milk. Similarly, they say that if you want to make a pure element, then we need the atom of same kind. You cannot mix different atom and say it is a pure element. Okay, it should be same atom to form the element here or pure element here. Number 3, what we have here, all the atoms of same element have the same property. That means if I take 1 gram, 1 gold atom, make it 1 gold atom, and on the other side I have taken another gold atom, second gold atom. Okay, now although it might be two different gold atom, but their properties will never vary. Okay, this gold atom, whatever the properties this gold atom is going to have, the same properties is going to be with the another gold atom. Okay. Number 4 is atoms of different element are different from each other. It means that if I take one gold atom, if I take another silver atom, they are two different elements, isn't it? So these two different elements cannot have the same properties. Similarly, what if I can say here, I said that there are how many elements are there? 118 elements. That means there will be 118 elements. These 118 elements, okay, they will not have the same properties. Okay, all will be different from each other. Some elements might be very much similar to one another, but if you see them chemically or physically, they will not be similar to each other. They will be exactly different from each other. Means one atom is going to be different with the another atom. That means if I compare here one gold atom with another silver atom, that means gold and silver, they are not going to have the similar chemical properties. Okay. So our next topic is molecule. Okay. Make it very simple. When you try to understand any type of things in science, try to make it very simple here now. This molecules means when two, okay, or more than two elements or two or more than two atoms, if they combine. You cannot say element here. Okay. If you say here atoms here. When two or more than two atoms, it might be of the same type of atom or it might be of different type of atom. If they combine together, then they will give rise to molecule here. Suppose like H2 is a molecule. Similarly, if I write N2 is a molecule, similarly if I can write here Cl2 is a molecule. O2 is also a molecule here. So why we are calling it a molecule? You can see here this H2 is made up of what? H plus H. That means two atoms of hydrogen have combined together to give rise to what? H2. Isn't it? That means here the elements which are used here to form the molecule are the same element, not different element, isn't it? So we can say that these are the molecule of same element. Okay. And if you have another example, like if I take here NaCl, if I take here like MgCl2 or KOH, okay, there are many more are here. Now you can see here that this is a sodium atom and this is a chlorine atom. Now when this sodium atom reacts with chlorine atom, they give rise to sodium chloride. But here you can see the sodium and chlorine are what? Two different type of elements. They are not same element, they are different elements. That means when two atoms or more than two atoms of different element, they combine together to form a substance, and those substances are known as molecule of the different atoms. Okay, molecule of different element or molecule of different atoms, you can say here. Now the problem here is that now we have the formula for NaCl. Okay, that means before Na was separate, means Na was different, okay, and Cl was different here. Now this Na and Cl, they combine. That means whenever I am talking about combine, that means they are not going any physical changes. Okay, they are going to go chemical changes here. Now these two will combine and form NaCl. Okay, now it's just like you are taking two papers, okay, and you are trying to stick them. Now if you want to stick two papers together, what will be required? Something will be required here. That means you cannot fix the two paper together, or you cannot fix the two wood together. Okay, for fixing the two wood together or two paper together, what is going to be required here? Means maximum of you will be saying that we need a glue here. Okay. So if you see here now, that to combine these two elements, I am just talking about paper. Okay, two paper we need what? Glue here. But to combine these two elements, you cannot combine them or you cannot join them by the help of glue. Okay, we need some other thing. That very thing is known as chemical bond. Okay, now whenever two elements they combine together, okay, so they will be attached to each other by a force. Okay, that force is known as chemical bonding here. That means there will be a bond between Na and Cl which is going to hold them together so that they don't get separated. Okay, and we can separate them, but for separating them we will be requiring some other process. But if you want to combine them, or when the element is formed after combination, this is formed only because of the chemical bonding between the two elements. Okay, and this chemical this chemical bonding is what? Very strong. Okay, and you cannot break them very easily here. Okay, so our next topic is our difference between mixture and compound. Okay, all of you know what is the meaning of mixture. Here means when you add two different type of things together. Okay, if you are adding it physically, then it will become a mixture. Okay, suppose like if you want to understand this particular concept, okay, it will be very easy to understand if I take a example of the mixture that we used to eat from the vendor. Okay, so in the mixture, the vendor used to add various types of things. But if you go and ask the vendor to give for 10 rupees mixture, okay, so what he's going to do here, he's going to add a different type of things that are available to mix the mixture. But if you notice him, he will never take the things in a systematic way. Okay, he's going to take it randomly. He's going to take randomly whatever things are available. That means whenever he's going to add the onion or add the butter and all, he is not going to use it like for a fixed proportion. Okay, just he will be taking it randomly and he's going to add it. Okay, so now here first of all here what they say is if you want to make a mixture, or in a mixture whenever you are going to add a substance, the substances are add in any ratio. Means the ratio of mixing the one substance to the other substance is not fixed. Okay, it can be anything. But when you make a compound, okay, in a compound the substances which are mixed, they are mixed in a fixed ratio. Okay, the ratio is not going to get changed. Suppose like if I want to make a compound of water, in the formation of water we will be requiring 2 atoms of hydrogen and 1 atom of oxygen. If you say no, I will take 3 atoms of hydrogen to make water, no, that's not going to happen. Okay, because if you want to form the compound of water, you will be requiring only 2 hydrogen atom and 1 oxygen atom. Number 2, what they say here, mixtures are combined physically. Okay, and here the compounds are combined chemically. That means you cannot form the compound by just what to say like by adding it by your hand. Okay, by physically it is not possible. But for making a mixture, you can add it by your hand. Okay, and you can make it the mixture here. But for compound, you have to undergo a chemical reaction. Okay, only after undergoing the chemical reaction, they are going to form the compound here. Number 3, what they have written here, compounds of mixture retain their individual properties. Okay, and here what is written here, compounds have entirely, sorry, this is your mixture. Okay, mixture retains their individual property. That means when you make a mixture, suppose like when I'm talking about the mixture that you used to buy from the shop. Okay, when you eat the mixture, you will be getting the taste of onion also. You are going to get taste of butter and whatever things are added, all the taste you are going to get. That means whenever you are making a mixture, the mixture they are going to retain their individual properties. Whatever properties that each substances have, they are going to retain it. But it is not same with the compound. In a compound, if you try to add 2 substances, then whatever the outcome you are going to get, that outcome will be totally different outcome. It is not going to have any type of properties related to what they were having before. For example, if I take hydrogen gas and oxygen gas. This hydrogen is a gas and this oxygen is a gas here. Now when these two will react, they are going to form what? Water. Now this was a gas, but this is what? This is a liquid, isn't it? That means 2 gaseous substances, they reacted together and they form liquid. And the properties of water is going to be totally different from the properties of hydrogen and oxygen. Okay, this is what I have written here. Compounds have entirely different properties with the substances they use for making the very particular compound here. So what you get from here, that substances can be mixed in a mixture. Okay, mixture can be mixed in any ratio, but in a compound you have to be in the fixed ratio. For making a mixture you require only physical process, but for making a compound you require chemical process. So then the mixture going to retain all the properties of the substances which have been added here, but in a compound the compound is going to get formed by the mixing of the elements or substances is going to be totally or entirely different from the before one. Topic is symbols. Okay, when we're talking about symbols here, we're talking about the symbols of the element. Okay, now we see, because as you go in the higher classes, we are going to undergo, okay, or we're going to find many type of chemical reaction. And when you write the chemical reaction, if you don't know the formula or the symbol, okay, then it makes the equation more longer. Okay, so to make the equation shorter and to do it more appropriately, for every element they have given some symbols to them. Okay, now what is the meaning of symbol here? Symbol is nothing but the short form which is used to refer to an element. Because if you want to refer to an element, you can just write a short form, and with the short form you will be able to say that which particular element it is now. For example, hydrogen. Hydrogen, the symbol is H. Okay. When I go to oxygen, the symbol will become O. Okay. If I go to potassium, the symbol will become K here. So now maximum time, if you see, okay, the name of the or the symbol of the element is nothing but the first letter of this very particular element name. Here the element name is what? Hydrogen, the symbol is your A. Here is oxygen, the symbol is your O. Okay, but sometimes what happens, the first letter, okay, because we have only 26 letters in our whole book, isn't it? So 26 letter means we cannot write the 118 element with this 26 letter, okay? So there will be some collision of the name, okay? Suppose like if you see here, it is potassium is given here K. Why potassium was given K? Because before potassium, one substance comes which is known as phosphorus. Okay, each symbol is already given as P. Now since the phosphorus symbol is already P, they cannot give the symbol of potassium as P, okay, because it will collide with each other. Okay, that's why they have given the, or to say another symbol like known as here K. Okay, but there are some other element like, if I go for chlorine, okay, chlorine symbol is Cl. Okay, why it is Cl? They could have given here C also. Okay, but because before chlorine one element comes which is carbon, and his symbol is already given as C. So since it is given as C, you cannot write as C again. Okay, so they have given as Cl. Okay, and the giving system or the procedure is very different. Okay, it depends on the particular person who have found every particular element. Some of the name of the element is given only on the basis of the person who have find the element. Okay, so, but maximum of the time you will notice that the symbol is either the first letter or the first two letters. Suppose like if I come to magnesium, or if I come to calcium. Okay, so magnesium symbol is what? Mg. Calcium symbol is what? Ca. So you can see here for calcium what they have used here, they have used the first two letters for giving it the symbol. But one thing that you need to follow here, when you are writing the symbol of magnesium, you cannot write M capital G. Okay, the rule says that here that if you write the first letter will be always capital. Okay, but when you go to the second letter, it should be always small letter. Similarly, if you see here, I written C in the capital, but N is in the small letter. Similarly, M is in capital, G is in the small letter, C is capital, A is your small letter. Okay. Now, one more thing that you need to put in your mind is that suppose when you are forming a compound called sodium chloride, NaCl. Okay. Now, many of them have a tendency of writing like this, NaCl. But this is not correct. Okay, why it is not correct? Because this is sodium. Sodium, we know that the symbol is Na. Okay, and we know the chlorine symbol is what? Cl. So you cannot write a small letter C. Okay, we have to write here the capital letter C. You remember it. You cannot just go with the flow like NaCl. Okay, chlorine, sodium is different element, chlorine different element. When two different elements come, the different elements will be always written in the form of capital letter. Suppose like if I come to the formula for magnesium hydroxide, you can see here that we have three elements here: magnesium, oxygen, and hydrogen. Since we have magnesium Mg, magnesium is different element, so we written Mg here. But oxygen is what? And then another different element, so you can write in capital small letter. Okay, we have to write in capital letter. Similarly, if you come to capital A, here H is a hydrogen. Hydrogen again a different element. So again you have to write in the capital letter. You cannot write like this. Okay, if you write like some of them, you might write like this OH, but that is not correct. Okay, OH, because if you write OH, it will justify or it will show that these two are the same element, but these two are not the same element. O is different, H is different. So just to make it clear that H is different element, we have to write them in the capital letter here. So this is the way how the name of some of the elements are given. Now our next topic will be your formation of compound. Now for the formation of compound, the concept is very big, okay, and this concept have not been discussed in our book here. So for that, for your easy understanding, what we can do, we can write the valency of some of the element, okay, and how to find out the valency we will be discussing in the our next class, that is in the next class means when you go to class 7, okay. Now I'll talk about some of the elements like hydrogen, okay. This hydrogen valency, okay. If you don't know, the meaning of valency is the combining capacity of an element. It means how many atom is going to combine with how many atom with other element. It is known as the valency here. So the valency of hydrogen is how much here? 1. Valency of carbon. Valency of carbon is 4. Valency of oxygen is 2. Valency of sodium. Sodium is 1. Then if you go, magnesium is 2. Chlorine is 1. Aluminium is 3. Potassium is 1 and calcium is 2. Okay, I have just given the name or the element, the valency of few elements, okay. I have already said that there are 118 elements, that means 118 elements going to have 118 valencies, okay. We are not discussing all of them, we are discussing only some of them. Now you see what is the use of the very particular valency here. Now suppose if I tell you that what is the formula for water, okay. Now I want to find the formula for water here. Now you have to know that water is made up of what? You should know that water is made up of hydrogen gas and what gas? Oxygen gas. You have to just write the symbol, okay. I am showing you how to form the formula here. So you write the symbol, that is H and that is your O, because you know that the water is formed by hydrogen and oxygen here. Now you come to here, okay, and see the valency. This is hydrogen. The valency of hydrogen is how much here? 1. Come to oxygen. This is oxygen. What is the valency of oxygen? It is 2. So once you write like this, after writing what you have to do? You have to interchange, okay. Make it interchange, okay. These 2 will come here, downside, okay, and this 1 will come here. So, or if you combine them, you should know that if you have 1 here, no need to write 1, okay. It will become H2O. If you don't write 1 also, it will be considered as 1 only. Suppose now if I tell you to find the formula for magnesium chloride, okay. Now first of all, we have to see that what are the elements used here, okay. This is magnesium and chlorine here. The magnesium symbol is what? Mg. Chloride means chlorine. Chlorine symbol, if you see from the previous lecture, you will be getting that the chlorine symbol was Cl. So once you write the symbol of the element used for making the magnesium chloride, then you have to go to the valency here. Come to magnesium. What is the valency of magnesium here? The valency of magnesium is 2 here. Come to chlorine. What is the valency of chlorine here? It is 1. So right here 1. Then again like before, what we have to do? We have to exchange it. That is Mg, right? Mg right here Cl. How much is going to come from here? It's going to be, he is going to get how much? 1. And you can see how much is Cl is going to get? It's going to get 2. If you combine it, you are going to get MgCl2. In this very particular way, all the compounds are made.